Okay, so good morning everyone. This is our first online lecture. Actually, we are all facing times that none of us has witnessed before, so it's completely new for me to do this recording, as it is new for you to listen to lectures online. I hope my voice will not be boring for you or encourage you to sleep. Okay, please stay awake with me. I will try to change my voice every now and then in order to keep you awake. But let's look at the bright side. Hopefully we'll get out of this stronger, and we will have a lot to tell our friends from this hopefully interesting experience. Okay, so I will go again through the appendix of chapter 5 because we haven't finished this part yet, and it is extremely important. So previously we have looked at the consumer equilibrium, what was called the equimarginal principle, which was this equation that was equating the marginal utility of x divided by the price of x equal to the marginal utility of y divided by the price of y, and so on for all the goods that the consumer will be consuming, and this should be equal to the marginal utility of income. Okay, but we took it as it is. In this appendix, we will be trying to convince you how this equation was derived through a geometrical analysis of the consumer equilibrium. So we are going to use a graph in order to reach the same equation that we discussed previously. Okay, so let's remember together what was the consumer problem about. Every one of us, so every consumer, has unlimited needs. We have many things that we want to consume. However, our financial resources are limited. Our income is limited. Okay? So we are facing a dilemma here. This implies that a rational consumer, which this theory assumes that every one of us will try to maximize his or her utility, should pick up the consumption bundle that is affordable given our limited financial resources, and at the same time this consumption bundle should give us the maximum level of utility. Okay, so this is the consumer problem that we want to solve. What will be the consumption bundle that is affordable, okay, which means that it is satisfying the second point above, and at the same time it should give us the maximum level of utility. This is the consumption bundle that we are looking for, and that we will be using a graph in order to reach this consumption bundle, and this bundle will be achieving the consumer equilibrium. Okay, so let's take an example to make this clearer. Suppose our consumer is faced with two goods that he needs to decide how many units of each to consume. Suppose he is facing good C, which represents clothes, and good F, which represents food. Okay, now the consumer wants to decide how many of clothes and how many units of food he should be consuming in order to maximize his utility given his limited income. So the required ingredients to be able to determine how the final amounts of goods C and F will be chosen are the following. The first ingredient is we need to know the preferences of our consumer. Okay, this corresponds to number 1 in the previous slide, which is that our consumer has unlimited needs. So this consumer has to tell us, in order to help him decide how many units of each good to consume, we need to know, so this consumer needs to tell us, if we will assist him, about his preferences, okay? Because these preferences are related to his unlimited needs and wants. So this is the first ingredient. The second ingredient that we need to know is this consumer's budget constraint. We need to know information on his income and information on the prices in the market of these two goods in order to be able to draw this consumer's budget constraint. Okay, so let's start with the first ingredient, which is the consumer preferences. So do we have in economics any tool that could help us represent our consumers' preferences? Yes, we have. This is what is called the indifference curve. From its name, it is a curve on which there are many consumption bundles. However, these consumption bundles share one property, which is that for the consumer, these consumption bundles are giving him the same level of utility. This means that our consumer will be indifferent between any of these consumption bundles that lie on the same indifference curve. So if you look at the curve in this graph, on this curve we have 4 consumption bundles, A, B, C, and D. For our consumer, these consumption bundles are indifferent, which means that he is indifferent between consuming consumption bundle A or B or C or D. So what are the features of this indifference curve? Actually, this indifference curve has many important features that are very important for us and will help us in our analysis later on. The first feature is that this, as you can see, this indifference curve is convex to the origin. If you look from the origin, which is point 0 and 0, okay, you can see that this curve is convex. Okay, what does this mean? This means that the slope of this curve decreases as we move to the right. As we move from point A to point D, as you can see, the slope is decreasing. This means that our curve is getting flatter and flatter as we move to the right. Okay? This reflects a very important property in economics, which is called the law of diminishing marginal rate of substitution, MRS. So what is MRS? Marginal rate of substitution, or MRS, measures how a person substitutes one good for another. From its name, it's marginal rate of substitution, how a person substitutes one good for another. So the scarcer a good, the greater its substitution value. What does this mean, and why is the substitution value of a scarce good higher? If you remember the law of diminishing marginal utility, okay, so according to this law, the lower the quantity we have of a good, the higher its marginal utility. So by the same thing, the scarcer a good, the higher its marginal utility, which means that if we have scarce amount of a good, its marginal utility will be higher for us, which means that we will be willing to substitute more of the other good to get one more unit of the good that we are having scarcity of. Okay, so as you can see from this graph, it is clear that from moving from A to B, from point A to point B, you will be willing to give up 3 units of clothes in order to get 1 extra unit of food. Okay, so moving from point A to point B, the consumer will be willing to give up 3 units of clothes in order to consume one extra or 1 more unit of food. Okay, so this is the marginal rate of substitution between points A and B. However, moving from B to C, as you can see, now the consumer will only be willing to give up 1 unit of clothes in order to consume 1 extra unit of food. Okay, so as you can see, the marginal rate of substitution is decreasing. And finally, moving from C to D, the consumer will only be willing to give up half a unit of clothes, okay, if clothes was divisible, in order to consume one extra unit of food. Okay, again, as you can see, the marginal rate of substitution is decreasing, okay, as we move to the right. So initially, when the consumer was having a small amount of food, which means that for him food was a scarce item, okay, he was willing to give up a lot of clothes in order to consume one more unit of the scarce item. But as he moves to the right, which means that now he no longer has scarce amount of food, okay, so then he will be willing to give up less and less of clothes in order to increase the quantity he is consuming of food. Okay, so if we try to join points A and B, we'll find that the slope here is equal to 3, which is the 3 units the consumer is willing to give up of clothes in order to consume one more unit of food. But joining points B and C, we'll find that the slope now is equal to 1. And joining points C and D, the slope will be equal to half. These slopes, okay, the slopes of this indifference curve are called the marginal rate of substitution, i.e. the slope of our indifference curve is the same as the MRS, or the marginal rate of substitution. Now I will jump to slide 8 because I have already explained all the next slides on this graph. It was important for you to look at the graph and listen to the explanation at the same time. So we are done with slides 5, 6, and 7, and now we are going to jump to slide 8. We agreed that the slope of the indifference curve is called the marginal rate of substitution. But now we need to derive an expression for the slope, or for the marginal rate of substitution. So let's look at the arc between points A and B, consumption bundles A and B. We know that moving from point A to point B, or from consumption bundle A to consumption bundle B, total utility remains constant. Why? Because we are on the same indifference curve, and we said that our consumer should be indifferent between consuming bundle A or consuming bundle B. So moving from A to B, total utility should remain constant. This means that the utility lost from consuming less of C, of clothes, by moving from A to B, must be matched by the utility gained from consuming more of F when the consumer moved to point B. So moving from A to B, the consumer is now consuming less of clothes and more of food. However, his total utility should remain fixed or constant. This means that, or this implies that, the utility lost from consuming less of C must be matched by the utility gained from consuming more of F. How can we write this? So the utility gained from consuming more of F will be marginal utility of F multiplied by the change in the amount consumed of food. This should be equal to the marginal utility lost from consuming less of C, which is marginal utility of C times delta C, and this is a loss, so it is preceded by a negative sign. They should be equal. Why? Because we are staying on the same indifference curve. If we rearrange these terms, we obtain the following. Delta C over delta F, which is the slope of our indifference curve, delta C over delta F, will be equal to minus mu F over mu C. And this is the first ingredient or the first part of the consumer equilibrium equation that we aim at reaching. I'd like to remind you that our consumer does not have just one indifference curve. Actually, he has many indifference curves, okay? And each indifference curve has a number of bundles. These bundles are indifferent to the consumer, which means that they give him the same level of utility. So if we look at indifference curve 1, okay, this indifference curve will have all consumption bundles that give the consumer a certain level of utility. Let's say it is equal to U1. And look at indifference curve 2. On this indifference curve, the consumer will be having all consumption bundles that give him another level of utility. Let's say it is equal to U2. However, this level of utility is higher than U1, and so on. So as we move northeasterly, the level of utility increases. So the higher the indifference curve, the higher the total utility that the consumer is getting from these consumption bundles. So U4 is higher than U1. Okay, so we agreed again, let's summarize this, that the consumer preferences, which is a very important ingredient in the consumer problem because it represents the unlimited needs and wants of the consumer, these preferences can be represented by an indifference curve. Actually, it is the consumer who will tell us which consumption bundles, okay, give him a certain level of utility. So if we look at this graph, which is having close on the y-axis and f on the x-axis, okay, in this region, we can think of hundreds of consumption bundles, okay, but it is the consumer who will tell us which consumption bundles give him the same level of utility. For example, according to our consumer, he said that consumption bundle A, B, C, and D give him a certain level of utility, let's say equal U3, okay? But the same consumer told us that lower consumption bundles, okay? Let's think of consumption bundles below A and below B, below C and below D. He will tell us that these consumption bundles will give him a lower level of utility, and so on and so forth. So the consumer is the one who will be able to rank the consumption bundles in a way, okay, where he collects all consumption bundles that give him the same level of utility, among which he is indifferent, and we are going to connect them, and these will lie on one indifference curve. And he will tell us what consumption bundles give him higher level of utility, and we're going to connect them together, and this will be a higher indifference curve. He can also tell us other consumption bundles that give him lower level of utility, okay? We can then connect them all together, and we can form a lower indifference curve to U3. Now we will start looking at the second ingredient of the consumer problem, which is the consumer budget constraint. So we agreed that our consumer is financially constrained, which means that he has a limited income. And we need now to draw this budget constraint. So we need two types of information. The first one is how much does our consumer earn? What is his income? The second information in order to be able to draw this budget constraint is to know the level of prices in the market for our two goods, F and C. So let's assume, as an example, that our consumer earns $6 per day. This is his income, and he is confronted with fixed prices for food and clothes, where the price of food is 1.5 and the price of clothes is 1. In order to be able to draw the budget line, we need at least 2 points. The easiest points we can get are the horizontal intercept and the vertical intercept. Okay, let's move to the next slide, to the graph, in order to better understand what we mean by the horizontal intercept and the vertical intercept. Okay, so now we have this graph where we have clothes on the y-axis and F on the x-axis, and we need to draw the consumer's budget line. As we said, we need 2 points in order to be able to draw this budget line, because by connecting these 2 points we will have the consumer's budget line. The easiest points we can get are the horizontal intercept and the vertical intercept. What is the horizontal intercept? The horizontal intercept is the point where the consumer spends all his income on only the good that lies on the horizontal axis or the x-axis. So in our example, the price or this point will be determined by dividing the consumer's income, which is $6, divided by the price of food, which is $1.5. Because if the consumer will spend all his income on food, okay, we need to know the price of food in order to know how many units he can buy of food. So by dividing income by the price of food, we will know how many units the consumer can consume of food if he spends all his income only on food. So this will be equal to 6, which is income, divided by 1.5, which is the price of food. This will be equal to 4. So our horizontal intercept will lie at 0.4, where the consumer spends all his income only on food. To be able to get the vertical intercept, we will do the same. Suppose that the consumer will spend all his income on clothes. How many units of clothes can he consume? In order to know this, the consumer has an income of 6 and the price of clothes is 1. So by dividing 6 by 1, we know that the consumer can consume 6 units of clothes if he spends all his income on clothes. So our vertical intercept will be at 0.6. So connecting these 2 points together, we will have the consumer budget line. So what is this budget line? All points on the budget line are affordable for the consumer. They represent consumption bundles where the consumer will be spending all his income on the quantities of these consumption bundles. Okay, so what are points that lie to the right of the consumer's budget line? Any point that lies to the right of the consumer's budget line represent a consumption bundle that is not affordable for our consumer, which needs a higher level of income or a lower price of the good in order to be able to get these consumption bundles. So points to the right are unaffordable for our consumer. Points to the left, on the other hand, represent consumption bundles that are affordable for our consumer. They lie inside the budget constraint of the consumer. However, they are not optimal. Why? Because our consumer will not be spending all his income in this case, and this will not be acceptable. This is not assumed in our consumer problem. So we are assuming that our consumer will be spending all his income. So any consumption bundle that lies inside the budget constraint, which means that it lies to the left of the budget line, will be affordable, but it's not optimal, because the consumer can do better by spending his income on higher quantities of the 2 commodities. He can be happier, he can maximize his utility by moving to the right and staying on the budget line itself, not inside the budget constraint. Okay? So now we need an expression like we did with the indifference curve. We need an expression for our budget line. So the slope of the budget line, in order to be able to get the slope of the budget line, it will be equal to the change in the vertical intercept, okay, from the origin, divided by the change in the horizontal intercept, again from the origin. So this will be equal to income divided by the price of clothes divided by income over the price of food. Okay, this will give us an expression for the slope of the budget line, which will be equal to minus PF over PC. Why is it minus? Why do we have this negative sign? Because as you can see, the budget line is downward sloping, which means that in order to move from one consumption bundle to another, which means that you want to consume more of one good, you have to give up some quantity of the other good. So there is always this negative relationship. Okay, from our example, if we look at the information in our example, this slope, which is PF over PC, will be equal to 6 over 4 or 3 over 2. What does this 3 over 2 tell us? This tells us that if our consumer gives up 3 units of clothes, okay, he can have enough funds or enough money to buy 2 units of food. This is what we mean by 3 over 2. Giving up 3 units of clothes, okay, he will have enough funds or enough money, which is 3 times 1, because the price of clothes is 1. So he will have now $3, okay, and these $3 will enable him to buy 2 extra units of food, because the price of food is 1.5 each. Okay, so this is what we mean by the 3 over 2, the slope of the budget line. Now we have the 2 ingredients separately. We have the slope of the indifference curve, okay, and we have an expression for it. We have the slope of the budget line, and we have an expression for it. Now, in order to reach the consumer equilibrium, we need to put these 2 ingredients together, as we will see in the next slide. Now we are in a situation where we are getting closer to our consumer's equilibrium. So we have 2 separate ingredients, which are our consumer's preferences in the form of a set of indifference curves, or what we call an indifference map. And we also have our consumer's budget line. By putting these 2 ingredients together, okay, on the graph that we can see now, okay, so we have our indifference map and we have our consumer's budget line. We put them together in one graph. Now we want to know what will be the consumption bundle that will maximize our consumer's utility given his financial constraint or given his budget line. Okay, so our consumer will choose from among the affordable bundles, okay, because we agreed that the consumption bundle that the consumer should choose should be affordable for him. He cannot choose a consumption bundle to the right of his budget constraint because this is not affordable. He should not choose any consumption bundle inside the gray region, which is inside the budget constraint, because this is not optimal. He can do better. Okay, so we know that this consumption bundle should lie on the dark gray line, which is the consumer's budget line. Okay, so the consumer should choose a consumption bundle that lies on his budget line, which means that it is affordable, and at the same time this consumption bundle should maximize his utility, which means that from all consumption bundles that lie on the budget line, the consumer should choose the one that lies on the highest indifference curve. So as we can see, there are many points of intersection between the indifference curves and the budget line. Okay. However, there is only one that lies on the highest indifference curve, which is point B, because on the northwest of point B, there are two other points of intersection between the budget line and the indifference curves. However, they lie on lower indifference curves, on indifference curve U2 and U1, which means that they give our consumer a lower level of utility. So if he chose any of these two consumption bundles, they will be affordable, true. However, they are not maximizing his utility. He can do better with his limited income. So again, the consumer will be choosing a consumption bundle that lies on his budget line, which means that it should be affordable for him, but at the same time lies on the highest indifference curve. And this is satisfied only at point B. Okay? Any other point that represents a consumption bundle that lies on the budget constraint or the budget line, okay, you will see that any other point will be lying on lower indifference curves, which means that if the consumer chooses any of these points, he will not be maximizing his utility. The only point that satisfies the two conditions, which are condition 1, that the consumption bundle has to be affordable, condition 2, that it should maximize the consumer's utility, i.e. it should lie on the highest indifference curve. These two conditions are satisfied only at point B. As you can see, point B, okay, is tangent to the indifference curve. In other words, at point B, the indifference curve U3 is tangent to the budget line. What does tangency mean? Tangency means that the indifference curve at point B touches the budget line. So it does not intersect the budget line, it just touches the budget line. Okay, so what are the implications of this point of tangency, of having our consumption bundle at the point of tangency between the indifference curve and the budget line? The implications are the following. I believe in mathematics, in high school, you took that a point of tangency satisfies this condition, that the slope of the two curves that are tangent to each other should be equal. So in our graph, at point B, which is a point of tangency between the indifference curve, or point of touching between the indifference curve and the budget line, at this point of tangency, the slopes of the indifference curve and the budget line should be equal. Okay, so now we are getting closer to our consumer equilibrium condition. So what is the slope of the budget line? The slope of the budget line is, as we said, minus PF over PC. What is the slope of the indifference curve? The slope of the indifference curve is minus MUF over MUC. So at point B, which is a point of tangency, these two slopes should be equal. So by equating these two slopes and rearranging, we will reach this expression. At point B, MUF over PF will be equal to MUC over PC. Does this ring any bells? Yes, this is our equimarginal principle, where the marginal utility that the consumer gets from the last unit he consumes of food divided by the price of food should be equal to the marginal utility he is getting from the last unit he is consuming of clothes divided by the price of clothes and these two should be equal to the marginal utility of his income, or of his dollar, or of his pound. Okay, so at point B, which is the solution to our consumer problem, which is the point of equilibrium of our consumer, we have MUF over PF equal to MUC over PC. We just got rid of the negative signs because both slopes have negative signs, so they cancel out each other, and we are left with our equimarginal principle. Now you are all able to use a graph that has a representation of the consumer preferences in the form of indifference curves, and has the consumer's financial constraint in the form of budget line, in order to help our consumer solve his choice problem. In other words, you want to help the consumer choose the quantities of each of the two goods he's facing that will maximize his utility given his budget constraint. And we saw using the graph that this consumption bundle, which will represent our consumer equilibrium, which we call the utility maximizing consumption bundle, will and should lie on the consumer budget line. In other words, it should be affordable, and at the same time lies on the highest indifference curve. And we saw that this consumption bundle happens only at the point of tangency between the indifference curve and the budget line. Now we want to see applications for this consumer equilibrium. Okay, so what will be the impact of a change in the consumer's income level, or a change in any of the prices of the two commodities that the consumer is facing? Okay, so we'll now apply some scenarios on our graph. We will start with an income change. Let's assume that our consumer is now facing half his initial income level. So initially he had $6 per day. Now let's assume that his income has been halved, and now he has just $3 per day to spend on clothes and food. So what will be the new equilibrium of the consumer? What will be his new utility maximizing consumption bundle? So we will move to the next graph in order to answer this question. So what do we have on this graph? On this graph we have our consumer's indifference map, set of indifference curves. Okay, we have our initial budget line, which lies on the line segment NM. Okay, and we have the initial consumer equilibrium lying at point B. Now let's assume that the consumer's income has been halved, which means that the consumer now has $3 per day to spend on food and clothes. What will happen to the budget line? Actually, the budget line will shift in a parallel way, or in a parallel fashion, inwards. Why? Because if we want to get the horizontal intercept and the vertical intercept, we'll find that the denominator is the same, because in the denominator of both intercepts we have the prices of food and clothes, which haven't changed. Okay, so it's only the income level that has changed, which is the numerator of both intercepts. This will result in a parallel shift from the initial budget line. But here it is an inward shift because the income has decreased. So now, in order to get the horizontal intercept, it will be 3 divided by 1.5, which is equal to at point M prime, and the vertical intercept will be 3 divided by 1 equals 3, which is at point N prime. So connecting the vertical and the horizontal intercepts, the new ones, okay, we will be forming the new budget line of our consumer, okay? And corresponding to this new budget line and the consumer's indifference map, okay, which hasn't changed because his preferences did not change, okay? Now, in order to reach our consumer new equilibrium, we will be moving on the new budget line N prime, M prime, okay, until we reach the highest possible indifference curve. And this, as you can see, will happen at point B prime, which is a point of tangency between indifference curve U1 and the new budget line N prime, M prime. So by connecting points B prime and the initial equilibrium B, okay, we will be having what is called a new curve, okay, which we call the income consumption curve, okay. This income consumption curve traces the utility maximizing consumption bundles corresponding to different levels of income of our consumer. Now let's look at a second application to our graph, which is a change in the price of food. Okay, so let's assume that the price of food rises from 1.5 to $3, while the price of clothing and the consumer's income is unchanged. What do you think will be the impact on the budget line? Which intercept will change and which will not? Okay, if you recall, okay, the horizontal intercept was equal to the income level of the consumer divided by the price of food, and the vertical intercept was equal to the income of the consumer divided by the price of clothes. So in our example, it is the price of food that has changed, okay? Neither income nor the price of clothes has changed. This means that only the horizontal intercept is what will change, okay? And the new horizontal intercept will be equal to $6, okay, the initial income, divided by 3, which will be equal to 2, okay? So we will now have a new horizontal intercept at the point of 2. The vertical intercept will not change because its two variables will not change, did not change, okay? So here we are having our budget line not shifting, but what we call pivoting. Pivoting because as if we are fixing the vertical intercept and we are just moving around the horizontal intercept. So the budget line will pivot in this example inwards, okay, to a new lower horizontal intercept. What will be the implication on the consumer equilibrium? Of course, we will have a new consumer equilibrium as we can see from the next graph. So what do we have on this graph? We have our consumer's indifference map, okay, as usual. We have the initial budget line at which is the line segment NM. We have a new budget line, which is NM double prime, okay. So as you can see, the budget line has pivoted inwards, where we are now having a new horizontal intercept at point 2, okay. So what will be the new consumer equilibrium? Again, the same steps. We will be moving on the new budget line because the new consumption bundle has to be affordable, but at the same time we want to reach the consumption bundle that maximizes utility, that lies on the highest indifference curve. So let's try to move on the new budget line until we reach the highest indifference curve. This will happen at point B double prime, okay, which is again a point of tangency. It should be a point of tangency, okay, not point of intersection, because we want to reach the highest indifference curve, okay, but at the same time an affordable consumption bundle. So this will only happen at a point of tangency, okay, which is B double prime. So this is the new consumer equilibrium corresponding to the new price of food. So if we connect points B and B double prime, we will be having a curve called the price consumption curve, okay, and this curve traces all utility maximizing consumption bundles, okay, corresponding to changes in the price of one good. Okay, so the question now is the following. Can we use the previous graph, which is the graph where we have food on the x-axis and clothes on the y-axis, to derive a demand curve for food? Recall the demand curve. It's a curve where we have price of food, for example, on the y-axis and the quantity of food on the x-axis. Okay. So can we use the graph where we have two commodities on the two axes to derive a demand curve for one of these two goods? This is the question. In order to be able to answer this question, recall that in order to draw a demand curve for any good, we need just 2 points. So we just need 2 prices and 2 quantities, okay? And from our previous application, okay, the previous slide, we were talking about a change in the price of food, okay, where initially the price of food was 1.5, and we examined what will be the new equilibrium if the price of food increased to 3. So now, as you can see, we have 2 prices of food. The initial one, which is $1.5, and the new one, which is $3. Okay, and for the initial one, which is $1.5, we had from the previous graph, okay, the consumer equilibrium achieved at point B, okay? This was the utility maximizing consumption bundle at point B, okay? And if you look at this graph, at point B, 2 units of food were consumed, okay? And when the price of food increased to 3, okay, we found out that the consumer equilibrium changed to be at point B double prime. And if you look at point B double prime, the quantity of food that will be consumed will be equal to 1. Okay, so now we have 2 quantities of food consumed corresponding to the 2 prices. So we are now in a situation to be able to draw the consumer demand curve, okay, having 2 prices and 2 quantities demanded. Okay, so the answer to this question is yes, we can use the graph where we have the 2 commodities on the 2 axes to be able to draw a demand curve for one of these 2 commodities, okay, and we never used anything related to marginal utility or anything else in order to derive this demand curve. We only based our derivation on the indifference map and the budget line.